Am I audible? Hello? Hello?
Yes, Roshan, you're audible.
Yeah. Okay, I will just start the class in around 3:10. Okay? I will wait for some others to also join.
Yeah, yeah.
I think I'll start now. So before starting the session, I just want to let you all know that all the presentation PDFs have been uploaded in the same drive folder in the sheet that might have been shared, with the solutions to the problems. Okay. So if you go through those problems, those solutions, and let me know if something is wrong. Okay, so that we can correct it soon. Okay. Mm, So in week 7, okay, let me share my screen. Yeah, I hope my screen is also visible.
Yes, visible.
Okay, so today's session will be about factorial design. Okay, so factorial design, as you all might know, it is an experimental setup where there are multiple factors, each factors having different levels, and you try to modify each of those levels in a certain factor to study their effects on a certain response variable. So you can think of the factors as your independent variables and the response. The change in the independent variable leads to a change in the response variable. Okay, and yeah, let's take an example where you have a pharmaceutical company who wants to study the effect of two factors, the dosage and treatment duration. The dosage, again, it's a categorical variable, low versus high, and the treatment duration, that is short versus long, on the efficacy of new drug, and the efficacy might be your response variable. Okay, so uh, going to according to this, we have two factors, and each factor is having two levels. So, how many experiments should we actually do to uh, get any effects? What is the effect of dosage, treatment duration, interaction effects, and so on? So, how many experiments we have to actually do in total?
4 experiments.
Okay, yeah. So, it's 2 by 2 is 4. Okay. So, the four treatment groups will be low dosage, short duration, low dosage, long duration, high dosage, short duration, high dosage, and long duration. Okay. And the importance of doing uh, this factorial design is it provides insights into the effects of multiple factors simultaneously. Okay. If you just do high and low for a single factor, you might not know how the interaction effects might also be for the response variable. Okay, and so I mean it might not be the most efficient way of doing it because I would say you have to do multiple experiments if the number of factors and also levels become more than three or four. That might be difficult to carry out, but it's certainly more beneficial than one factor at a time approach where you just take a single factor, analyze the effect, and come to a conclusion. Okay, uh, and also it will help you identify optimal conditions that you have to provide. Let's say if you're growing some organisms in a certain media, you need to know the concentration of each and every individual component, the optimal concentration, so that the organism can have maximum growth. Okay, and so the one that we discussed now, the pharmaceutical company case, it's an example of a full factorial design where we test for all possible combinations. Okay, and another example, you have three different factors for the taste of coffee, whether the temperature matters, the grind size of the coffee beans matter, and the brewing time. Okay, and so how many experiments we have to do in this case?
So 8 experiments.
Yeah, so you have two levels for each, and there are three factors, so eight experiments. Okay, So yeah,
Is there any background noise there?
I think so. Is it too much or
Yeah, it's like something mixer is running. Yeah, it's kind of disturbance.
okay? Okay. Then let me just try to change my Winnie Testament. Is it fine now?
Yes, it is.
Okay. Yeah. So yeah, this is the example for full factorial design, and there is a term called resolution where it refers to the smallest effect that can be estimated with the design. Okay, so if you have a higher resolution, you can detect smaller effects, but you need to require more and more runs. Okay, and resolution is typically denoted by an integer number with higher numbers indicating higher resolution. Okay, and the so full factorial design is the most, I would say, might not be most efficient, but can actually get you to concrete conclusions. Okay, since we study the combination of all the different factors and all the levels and so on. Okay, it provides insights into main effect, individual factor effects, interactions, and also the optimization of parameters. Okay, and yeah, moving on to fractional factorial design. In the fractional factorial design case, you only have a fraction of all possible combinations to be tested. Okay, you need not test for, in the previous example, there were 8 experiments. Let's say maybe you can come to a conclusion based on 4 experiments alone. Okay, and yeah, another example where you study the effects of 4 different factors, A, B, C, and D, on the quality of a cake. Each has 2 levels, so low and high. In this case, we'll have to do 16 experiments. Okay, 16 experiments, which can be, you need to bake 16 times to come to, a conclusion saying that this has to be in this level, this factor has to be in this level, and so on. Maybe in the fractional factorial design case, you can use a subset of these combinations where the low and high is being represented enough number of times in all the 4 factors A, B, and C, D. Okay, maybe you can get the optimal parameters using 8 experiments alone. So this is the whole idea of fractional factorial design. Benefits it saves time and resources, allows for efficient screening, and also this is also designed in a way that you can determine both main effects and key interactions. Okay. Any doubts till now?
But at the cost of?
Uh, so the fractional factorial design actually, it might not test for the all the combinations, right? Maybe there might be one combination that might have been missed, that might be the optimal. It may not always guarantee the optimal combination to be identified. It might be near optimal. So that is the only drawback, I would say.
Yes, yes, yes.
Yeah, you'll start with this problem. Okay. So you have a full factorial design where you have two factors, factor A and B, each having 2 levels, low and high. Okay. You want to estimate or calculate the main effects for A and B as well as if there is any interaction effect or not. Okay. Mm. So how do we go about it? What do we do? So first we need to add a page. So first we need to calculate effect for A. We need to calculate the effect for factor B and effect for interactions A and B. So what do we do for effect A? Okay, there are two levels, low and high. Okay, so what you do is take the effect for high, it's 15 and 20, right? So it will be 15 plus 20 by 2, take the average, minus 10 plus 12 by 2. It will be 17.5 minus 11, effect will be 6.5. Okay, I think similarly you can calculate for effect of B and effect of interaction. Okay, so yeah, I think I'll let you all solve this. Take some time.
It is 3.5 for B.
Yeah, it is 3.5 B. What about interaction?
For interaction 1.5.
I'm sorry, I didn't get you. For interaction,
1.5.
uh, so shouldn't it be? Yeah,
It's
3.5.
1.5.
Yeah, it is 1.5. Okay, similar to this. So what?
So once we
Yeah, yeah.
once we get this value, so how do we interpret this value? So
Uh,
6.5 means it has high effect.
yeah. So and if it's zero means no effect. So that's the only interpretation you can come here at this point. So more
And
the
negative means
yeah, tell me.
negative means
I think science does not matter. Maybe I think it depends on. So if you do high minus low and low minus high, that depends on if you what kind of levels you have here. If these categorical variables are actually ordinal. So last class I gave an expression of what ordinal is, right? What is ordinal?
yeah, I remember. Yes,
Yeah, yeah. What is an ordinal?
ordinal is, I think it's like a continuous data if I'm not wrong.
No, no. Low high that is ordinal. What what does that mean?
We have ordinal and nominal data, right?
Mm-hmm. Yeah, ordinal. So ordinal is again it's a categorical variable, but if you define low and high as your categories, obviously high has a ranking, a better ranking than low. It's higher, right? So that is what I mean by ordinal variable. If you have ordinal variables in your levels, and first get you subtract the effect of high from low and it comes out to be positive. So that in your case you can interpret it as if I increase the factor A, it leads to a positive effect. So there is an increase in the response variable, in this case the time here. So if it comes out to be negative, it's the opposite. Is this
Means
clear
the
or
opposite. It is
yeah?
opposite.
It
Okay.
is opposite in sense.
Like inversely proportional in a way.
I didn't get you. So If you do low minus high, it turns out to be negative, right? It will be minus 6.5.
Co- Correct.
Yeah, so if you, that means like if you lower or yeah, inverse effect. If you, wait a minute, I didn't. So in this case, if you move on from low to high, there is a positive effect means it's high minus low. That leads to positive effect. And that means if you move on to low to high,
Mm.
the response variable is also increasing. You do it higher minus lower. That means if you increase from low to high, there is a positive effect or a increase in response. Yeah, like that, like you said, it's an inverse thing that you have to make an interpretation for.
Okay. Okay. So can I say this like factor A has effect of 6.5 times? Uh, like uh, like how do you differentiate effect of A and effect of B? Just with numbers, or is there anything apart from that?
You can just say if your effect of A is greater than your effect of B, you can say that factor A has more influence on the response variable than factor B.
Okay. Okay. And no, I can't say anything with quantitatively using a
Hmm.
number
Hmm.
like
Yeah.
30%, 50%. I can't say that, right?
Yeah, because this response variable, no, that differs from problem to problem. It's
Hmm.
mainly
Hmm.
a qualitative thing that you can come to a conclusion for. It's not always quantitative. If you're
Okay.
comparing across
Qualitative is
multiple
there.
things in the same range of numbers, then you can come to a conclusion. I mean, quantitative conclusion. Yeah. But
Hmm.
in this
Hmm.
case, it's only qualitative.
Qualitative. Okay. Okay.
Yeah.
All right.
Any other notes?
Yeah, we can continue. Thank you.
Yeah. Okay. And so this is an example of what I would say a 2 by 2 factorial design. Okay. Design. Since you have two levels in two factors. Okay. And yeah, in this case, how many levels do we have?
Three levels.
Yeah. So this is a 3 by 3 factorial design. Okay. Yeah. Similar to last problem, we want effect of A, effect of B, and the response. And the interaction, sorry, not the response.
So in this case, we have three levels, right? So
Yeah.
if we had a low and high, we used to denote that low as minus and high as plus. Now, what
Mhm.
will we denote medium?
So when we try to calculate the effect, you always try to subtract the higher mean from the lower mean to get the effect of A.
So do we neglect medium?
It's not like neglective medium. So you are interested in which factor has the most effect on the response, right? It's not
Hmm.
like we are neglecting medium.
Okay. No, in
Ultimately,
the
the effect,
calculation, how do we consider? The question was, how do we consider the medium in the calculation?
one thing you can do is you can sum up. You can take you calculate the mean for low, medium, and high. Okay, you
Yeah.
calculate it. When you want to calculate the effect for A, you can simply uh, try to higher. So you find out which is the higher mean, which has a higher mean, whether it's low, medium, or high, anything. Okay,
Hmm. Hmm.
and
Hmm.
subtract it from the whichever is the lowest, highest minus lowest. So that will be your effect in this case.
Okay. Okay.
Sir, just one confusion. Suppose if the medium has highest mean and suppose lowest mean is of low, so we have to neglect that high one. That means we have to subtract medium from low.
Yeah. That is what you should do. Yeah.
Okay. Okay. And this is for only factor A and B. We are not going to do for any interaction.
Yeah. You
Okay.
calculate for effect A and B. Maybe I'll show how it's done for interaction.
Okay, sir. Okay.
I'll show
Please
that.
show that. So here we got lowest for medium. We have to
I
do
didn't hear.
high.
Yeah. Tell me.
Have to do highest minus medium in this case.
So let me just write out what's the. Yeah. If I write the mean for factor A, okay, your for mean for high will be point six three six, right? This is
6369. Yeah,
yeah.
6369. Yes.
Medium will be 0.557 and low will be 0.380. Okay. In
Uh,
this case, you just subtract the high minus low. Okay.
Actually, low and medium is reverse. Medium is
Yeah. Low is 0.557. Yeah. So you should do high minus medium. Okay.
yeah
That will be your effect for factor A.
0.177 we get.
Let me just write it out. So your effect for A is around
0.2566.
0.26666. Yeah. Similarly, if you write the mean for factor B, your high your high comes out to be 0.283. Your low is 0.822 and your medium is 0.469. Is this correct?
I couldn't calculate because I couldn't see the data again. One second.
Okay. Yeah, you could just calculate. Yeah.
Yeah, for high I got correct answer, so that's fine. Yeah.
Okay. Yeah. And the effect for B will be 0.5384.
1.3.
Okay. Is this clear till now?
Yes. High minus low. Highest value minus lowest value.
Yeah. But you have to do the interpretation properly, okay? Since you are getting a positive effect, okay, when moving from, so first is you're subtracting low minus high and you're getting a positive effect. So what should be the interpretation here?
So by decreasing the whatever that particular parameter will have higher effect.
Yes, so that is correct. Yeah. When moving from high to low, you are getting an increase in the response window. Okay.
Yeah.
Mhm. So how do we calculate interaction effects here in this case? Any ideas? How did you calculate in
AB.
the previous case?
So we'll multiply actually minus into plus is minus like that.
I didn't get you.
Low we take it as minus, high we take it as plus. So every interaction is to calculate minus into plus is minus, minus into
Mm-hmm.
minus plus, plus into plus is plus.
Okay.
But here we have medium. So medium, can we take it as 0 and do it?
No. I mean, those, it should not be like that, right? Maybe I will try to think of some other way. So how many interactions are possible here? You have low, medium, high. How many categories?
6 categories. High, low,
You said
mid,
six.
low, low, medium, low, low. I think 6.
Hmm? Not six. So medium is also there, right? So it's low, medium, low, high. That is one. Medium, low is one.
9.
Medium
Okay.
is one. Medium, high. Then high, low, high, medium, high, high. Okay.
9, 9. Yes.
Nine, nine.
Yeah. So that is nine. Okay. So what if you want to do? So you have to do the interaction for first thing you have to do is calculate the effect for all the nine individually. Okay. For low, you have to calculate for low, medium, low, high, and so on. Okay. Mm, let me just. First thing you want to do is low. Okay. How many data points are there for low?
Only one.
Yeah. So you can take it as mean low will be, I think it's 0.8507, right? 6. Okay. This is one. And you can get the interaction effect between low and low by doing, so let's say if I want interaction between low and low. Okay, this is one thing. You get the mean low, that is 0.8506, and you have to subtract the mean for low, that is 0.557. Okay, mean factor A low level. Okay, that will be 0.557. Okay, and you also have to subtract the mean for factor B low level. Okay, that should be 0.822. Okay, and you have to subtract the overall mean for this data. What's the overall mean? That will be around 0.524. Okay. If you do this, your interaction effect for low and low level in both factors will come out to be around minus 0.0037. Okay. Is this clear? What you have to do is calculate the mean for low and low first. How many ever data points you have. Okay. So this is only one, so only one. Okay. Then you subtract the individual effects. Okay. This thing low 0.822 low here, and the overall mean, that is x bar, that is 0.524. Okay. Once you do all this, you get the interaction effect for low and low. That will be this thing.
So where do you get 0.524 from?
So that's your overall mean. You just take the mean of all the data points.
Okay.
Okay. So similarly, can you do it for maybe high? Maybe you can try for high, medium, high, and low medium maybe. Okay. Just let me know the answers for these three. Okay. In total,
Please,
there are nine. You have to calculate it for nine, but just give me these three if it's correct or not. Okay. You
so
have
please go
the.
to data.
Yeah, tell me.
Yeah, please show the data so that we can.
Yeah, sure. I mean, is the background noise too much? Because if I move outside, I'm not getting good enough internet connection.
Yes, the background noise is there.
Okay.
The high is minus 1286
Let me just check.
minus
Minus.
1.286. High also we get only 1 point. So hence it is minus 1.286.
Okay. Let me just.
So
Okay. What about medium, high, and low, medium?
yeah, please show the data points. So
Okay. Yeah. Sure.
medium, high. For medium high, we have 2 points. So we have to take the average of that.
Yes.
And then what do you subtract it with?
Wait. Medium, high. There is only one data point, right?
Medium high or high medium. So we have to do 2 data points.
Yeah. It's medium for factor A, high for factor B. Okay.
Or it's always AB. Then it's only one.
Yeah.
Medium and high, 0.113198. But what do we subtract it with?
Huh?
What do we subtract it with?
Subtracted with. So factor A medium 0.380, factor B high, that is 0.283, and the overall mean, that is 0.524, that you have to subtract.
Okay.
You have the means here.
It's minus 0.0081.
minus 0.
0.0081.
Let me check. Then low medium data point is 0.259. Okay.
Medium high, I got minus 1.056.
I think it will be in the range of this thing only. But anyway, complete all these three. Let me say the solutions. So for low medium, the point is 0.259, and you have the means here. Remember, it's minus the whole thing. Okay, the 1 point you have here minus the mean for mean of level for factor A minus the mean of level for factor B, and then the overall mean you have to add.
Yeah, I'm again getting minus 1.056 for medium high.
Okay. Okay, I'll just write minus
0.56.
1.056. Okay, let me just keep it here. Then low medium.
Is that show the data?
Data point is 0.259. You can write.
Point.
Fine,
So
and
low medium is minus 0.595.
yeah, okay. So for medium high, okay, it's around, yeah, minus 0.0077. Yeah, it's pretty close to 0.0081, so that's not an issue. That this is the correct answer. Okay.
So
For
my
yeah, tell me.
where I'm going wrong. Medium high, the points are 0.131198.
Wait. Medium high, the point is 0.1311. Okay.
98
Yeah.
minus 0.3803
Let me just 131198 minus. So for you're saying for medium high, right? So for
yeah
medium factor is 0.380
3803
plus then
0.283
0.283
0.524.
minus 0.524.
Okay, this has to be okay added.
Yeah. So this
In
minus is
sir,
for the whole thing. Yeah, tell me.
hmm. In high also I got minus 0.238.
Yeah, that is correct. Minus 0.238 is correct.
So I did that
Yeah,
mistake.
I think you must have added this.
Yes. That mistake I've done. Yes.
And for low medium, it's minus 2422. Minus 0.2422. Okay. And you get the overall interaction effect, AV. You have to sum the effects of all the categories. Okay, low, medium, low, high, medium, low. So nine. You have to calculate it for nine different things. Okay. and the overall interaction will approximately turn out to be zero. Okay, you can try. You are free to calculate it for the other categories, total 9, and then also check. It will almost turn out to be zero. So you can say that there is no interaction effect present, where even when you change all these levels in both factor A and factor B. Okay, is this clear?
Yeah, it's clear.
Okay, okay. Moving on to this problem. This is what factorial design. You have three different factors, so and two levels for each. Okay, it is
2
a
power
2 by
3.
2 by 2, 2 by 2 by 2 factorial design. Okay, so total 8 experiments. You know how to solve this, right?
Yeah, yeah.
So I want, so how many in total effects will be there in total? You have an effect for A, B, C separately. You have A, B, B, C, C, A separately. So
and
6
ABC.
and O, A, B, C. 7. Okay. Yeah. Yeah. This is the data. You can solve it.
For factor 8 is to minus 28.5. Yeah, for factor 8 is minus 28.5.
Hello. Tell me.
Factor A minus 28.5.
Oh, just a minute. The effect of A is minus.
28.5.
Okay. Let me check them. Effect of B is
24.
24. Vector C is
minus 30.5.
everyone else getting the same solution?
Sir, still doing.
Hello? Yeah, tell me. Minus 28.5, 24, and minus 30.5. Yes, it is correct. Okay. Then for AB, two-way interactions. AB, vector BC, vector E. Okay. Oh, sorry. So yeah, three-way, right? You need the data set.
Yeah, so the effect AB is minus 14.5.
Yeah.
BC is 10.5. And AC is minus 4.
Yes. Everyone else also getting the same solution.
So I'm doing BC and AC. AB is up to AB is right.
Mm-hmm. What about BC and CA? Yeah, anyone else? BC, CA. What is the answer?
Sir, in AB I got minus 14.5. In BC I got minus 10.5. No, plus, sorry, 10.5.
BC you got minus
Minus 14.5.
BC,
No,
CA you
no,
got.
in AB. In AB I got minus 14.5.
Okay. Then BC,
BC 10.5.
okay. CA,
And ABC is 14.
this is correct. This is correct. What about CA? This is also correct. -4.
So
ABC, how did you do?
I just multiplied all this one, like what was taught in the lectures, no? So minus low means minus, high means plus. So first you multiply A into B if it is minus, and C is minus, minus into minus plus.
Mhm. Is it 14 or 8? Everyone else got the terms correctly for two-way interactions, right? Two-factor interactions. Is there any doubts on how to do it or no?
So ABC is minus 14.
Mm, minus 14 or plus 14 or 14 minus 14 or 8. Because while doing three-way, the effect for low, low in getting the 3, and effect for high, high, and high in getting the price.
Yes, it is minus 14, correct.
Okay. You have to actually, yeah, if you do it, it's minus 14. Mm, who else got plus 14?
It's minus
How
14 only, not plus, it's minus.
okay. In similar case, I think you'll get it as 7.25 and minus 7.25, I think. Here you'll get it as 5.25 and minus 5.25, I guess. Here it will be minus 2 and minus 2. Okay.
What are these? What you've written just now?
So this is for low, low, high, high. Same low, low, high, high, low, low, high, high. The values, the effect.
Okay, okay.
Yeah. Thing you. Yeah. If you do that, you'll get. You do the summation like we did before, like high minus low. You'll get these values. Okay.
Okay, sir.
This was the way as described in the lectures, right?
What?
This was the way how it was described in the lectures, right?
Yeah, yeah, yeah. Just now
Okay.
what we did is the way it was explained.
Okay. Because there is another method where You take into account both low high combinations and uh, high low combinations. Okay, you get the effect for each, and also what you can do is sum everything up. So yeah, there is because there are other directions where people also try to calculate the effects for a low, high, high, low, and then sum all the effects. That is also one way of doing it. But I think if it's like this as described in the lecture, then it's fine. No issues. Okay. And here is another problem. Similar to how we did it. Again, it's a 2 by 2 by 2 factorial design. Okay. Yeah. Try to solve this.
This is also in a similar way we can do it now.
Yes, yes, yes. Similarly, however you did it, same. It's 2 by 2 by 2 here and 2 by 2 by 2 here. Similar.
Yeah, I think we would be able to do it if we have done it previous one.
Okay, just wanted to try like because some people got some different answers here. So if this is fine, then yeah.
I think it would be fine. We can move forward.
Okay, because the other problem is also something similar, but you have like floating point values. So
It
you
just
want
it
to
just
try.
takes extra time. That's all. It doesn't.
Yeah,
Once we
yeah.
know the method, we would be able to do it. Yeah.
Okay. Yeah. Then you can take these two problems, and then if you want to work it out, you can work it out. If you have any doubts, you can ask. Like, do you want any other specific problem to be solved? Any other type of problems that you want to be solved? I can do it now. If you want a 3 by 3 by 3 factorial design problem, also I can give it right now. If you want to solve it.
The regression analysis will be explained in the next week.
Yeah, yeah, that's the final week, right?
Okay. Okay.
Yeah.
And ANOVA for these things will not be done, right? It is already done previously.
Yes. All the solutions are also there in the
Oh,
uploaded presentations.
okay.
Like, did I miss any factorial design concept or this is the whole thing?
That CCD, BBD,
Okay,
Taguchi, all those
okay,
explanations if you had.
okay, maybe, yeah, can do it.
So when do we go for CCD or when do we go for BBD?
Mm-hmm.
I did
Okay.
not see any specific demarcation in the uh,
Mm-hmm.
videos.
Yes, yes,
So I
yes.
thought
Okay.
I'll get an idea from this class. So
Okay,
because
okay.
I'm working in adsorption experiments.
Mm-hmm.
So when I see literature, some people have used CCD, some people have used BBD.
Mm-hmm.
And those who written BBD, they say BBD is used in literature because they've given reference to BBD papers.
Okay.
And those who have done CCD, they have given reference to CCD papers.
Mm-hmm.
And I want to know which one should be used and it is based on what.
Okay.
And also
Uh,
additionally, when I try to reproduce the results given in any of the papers using Minitab, I'm not getting the same output, the regression equation.
mm-hmm. Okay.
So I want to know, are you using any
The
Minitab or
regression.
doesn't? Yeah,
No, no, no. So if you were saying the output you are not getting properly, I still want to know what problem statement is. What's the input and output? I want to know that.
yeah. The CCD, if I take example or BBD, any example, they've taken three parameters.
Mm-hmm.
low, high, low, high, low, high. And they use CCD, they get around 17 experiments. I mean, 17 for BBD, CCD 20 experiments they get.
Mm-hmm.
And whatever the output, say adsorption, removal efficiency, that is our
Mm-hmm.
Y dependent
Yeah.
variable.
Yeah.
And that they will enter it, the value in the
Mm-hmm.
Minitab.
Mm-hmm.
So after that, when we analyze it, we get a regression equation
Yeah.
with interaction
So how many
terms in it.
factors? How many factors do you have and how many levels?
Two levels, three factors.
Okay. Mm-hmm. Yeah. Equation. Yeah. You get an equation, the response
Yeah,
variable and the independent variables. Yeah.
correct. That coefficients, I'm not getting same values.
Okay. How different is it?
Okay, how different it is means when I enter the data, right? Whatever the
No, no.
matrix it
How far
created,
are the? Yeah, yeah. How far is the weight differing? Is it like very insignificant amount or like it varies more?
uh, little bit changes there. So prior to that, when this matrix is created, like
Uh-huh.
minus plus,
Mhm.
there two rows I'm getting different in the mini tab than what is given in the paper. Checked for 2, 3 papers, both for CCD and BBD. The two rows I'm
Oh,
getting different combinations.
okay.
Yeah, so
Mm,
why it does happen? I'm not able to figure it out.
okay. Mm, maybe I have to look into it, but if based on the regression point, I can say because regression, if you try to do later, based on the experiments that you do, there are
Hmm.
three main methods for getting your coefficients.
Okay.
So there, in the regression case, there is something called OLS or ordinary least squares.
Mm-hmm. OLS.
Least squares, that is one way. You can have TLS or total least squares. There can be WLS, that is weighted least squares. So each method, it has its own assumption of how your data should be distributed, how your errors in your data might be distributed. So maybe the method that they use for getting those weights in the paper might be like OLS. Maybe yeah. In the other case, the Minitab might be using TLS. I'm not sure. So yeah.
Okay. Okay.
Yeah. So again, it depends on the downstream uh, so optimization framework that you use to get those weights. So it all depends on the numerical optimization at the end.
Okay. Okay.
But the CCD, I'm not sure why those two rows are different.
But anybody who are creates that particular BBD or CCD, the list
Yes,
of
yes.
experiments should be same.
Yes, so should be same. Yes, yes.
Yeah. So central points instead of three, they have taken five. So we also took
Mm-hmm.
five.
Mm-hmm.
So when you took five instead of 15, it came 17.
Okay.
By default, it will be three center points.
Yeah, yeah, yeah.
So when we took three central points, we got only 15 experimental runs. So
Okay.
in order to match with the paper, we took five central points. So that time it matched with the number of runs.
Mm-hmm.
But the combinations of the variables are not the same. Two combinations are coming different.
Okay. Mm,
Yeah.
it should be the same because this is not I mean, random way of deciding the experiments, right?
Yes.
CCD, it's just not random. So it should be the same, but I'm not sure. Maybe if I look at it, I've not used the software by the way.
Okay. Okay. All right. No problem then.
Okay, maybe I'll add more information about what CCD, BPD going to use and other stuff in the while I upload the recording.
Yeah, that will help us out,
Yeah.
including Taguchi methods. For some
Okay.
applications, people use Taguchi as well. But in
Okay.
my area of research, people use CCD and BBD a lot.
Okay. Okay. Yeah, I'll add that. That's not an issue.
Yeah, thank you. That's all from my side.
Okay. If there are no more doubts, I think we can end the session here.
Thank you, sir.
Yeah. Thank you.
Yeah, thank you.